Consider autonomous driving. A smart car needs to make reliable predictions about human behavior in real time in order to preemptively adjust speed and course to cope with a child's possible decision to abruptly cross the road in front of them. One may say, no problem. Deep neural networks can efficiently identify human actions in streaming videos as motion patterns. Yes, sure. But however, the later, I mean the child, may be deceiving, as humans can suddenly change their minds based upon their own mental processes, thoughts, motivations, and also based upon things they see around them. And in our example, children walking on the pavement towards the school may spot an ice cream van across the road and decide suddenly to dart across the road to get their ice cream. In fact, far more sophisticated functions need to be in place before artificial intelligence can be safely deployed in high risk and potentially dangerous situations. Really, it is a challenge. Machine must have theory of mind capabilities. So, you in your measure, I mean artificial intelligence, you should be familiar with and acquainted with the theory of mind. You have to figure out the meaning of theory of mind. You have to understand its principles and its application. And also, you should be acquainted with what the intersection of artificial intelligence and the theory of mind for human machine interaction by exploring different perspectives on that matter. And in order to provide machines with limited theory of mind capabilities, computer scientists will need number one, to work closely with psychiatrists, psychologists, and neuroscientists. Also, they need to develop new models according to the theory of mind. Number three, they need to formally define what problems need to be solved. Number four, they need to know how the results will be or should be assessed, how to assess the results of these models. So again, number one, you need to work closely with psychiatrists, psychologists, neuroscientists. You need to develop new models. You need to formally define what problems need to be solved and how to assess the results. All of these are requirements in order to be able to provide machine with even limited theory of mind capabilities. And you have to remember that the theory of mind is one of the cognitive capabilities that separates humankind from other species. And also, it captures an individual's ability to attribute mental states to oneself or to ourselves and to other individuals. It is developed at age 4 years and onwards, and it is our way, theory of mind is our way to understand others' beliefs, goals, thoughts, desires. And through the theory of mind, we can explain and predict others' behaviors, thoughts, desires, goals, beliefs. And for more advanced artificial intelligence, theory of mind becomes relevant for this scientific breakthrough. But after providing machines with limited theory of mind capabilities, a philosophical questions will need to be reflected on. That's whether a machine emulating a self, which includes a concept of the theory of mind, could be regarded as a true individual with actual theory of mind capabilities. Is it comparable to humans? This is it remains a philosophical question need to be reflected on. A machine emulating a self, which includes a concept of the theory of mind, could be regarded as a true individual with actual theory of mind. Is it comparable to humans? I think we have to reflect on this question, and I think we have to wait and see. Over and above theory of minds, we have more topics and issues that are significant in executing artificial intelligence. Among these significant issues and significant topics is creativity. What is the meaning of creativity? What is the meaning of creativity? We can, in general, define creativity as a process of developing novel and useful ideas. It can also be defined as the ability to produce different and valuable results or outcomes. And in order to be creative, you must have some characteristics. This involves producing lot of ideas, so you should be able to produce lots of ideas, and then you have you should have the ability to put ideas, even existing or new ideas, together into different combinations. Number three, you have to be able to analyze an idea, I mean break it down to take a fresh look at its parts. Number four, you have to be able to make new connections between facts, events, or observations that seem to be uncorrelated or unrelated. So we have four characteristics. In order to be creative, you should have these four characteristics. Number one, producing lots of idea. Number two, putting existing ideas or new ideas together in different connections or combinations. You have to be able to analyze or analyzing an idea or break it down to take a fresh look at its parts. Number four, making new connections between facts, events, or observations that seem to be correlated. And you have to reflect on these four characteristics and ask yourself which one of them, or which of them in general, are suitable for artificial intelligence, which one could be applied in artificial intelligence. in that case, we will talk about artificial creativity, not artificial intelligence. But which one of them, or all of them, maybe all of them, are suitable for the artificial intelligence? And we have also three forms of creativity. Number one, it is referred to as creation. Number two is named modification. Number three is referred to as synthesis. What is the difference between the three forms of creativity and which one of them is applicable for artificial intelligence? Creation. What is the meaning of creation? It means creativity that makes things. I mean, to make something out of nothing, to create something. What about modification? In modification, we don't create anything, but we change something that already exists so it can perform its function better, or perform a new function, or perform in a different setting or a different area or a different field, or it could be used by someone new. So in modification, you don't create nothing, you don't create something new, but you change something already exists so it can perform its functions better, or perform a new function, or perform in a new different settings, or can be used for some one new. What about synthesis? Synthesis means creativity that combines things. So in synthesis, you relate two or more things which are or which were not related before. And you are trying to relate between these two or more things together. Now, the question, which one of these three forms of creativity is more suitable for machine, or for robot, or for non-human intelligent agents? And you can figure out that synthesis and modification are more easier than creation, because in synthesis and modification you don't create something new, but just either changing something already exists, or just relate between two things already exist. Among other topics or issues that are significant in implementing and executing artificial intelligence, and that you have to understand it deeply, the difference between sequential and simultaneous processing. What is the difference between sequential processing and simultaneous processing? Sequential processing is also referred to as serial processing, and it is in contrast to parallel processing or multitasking processing. And we can define sequential processing as it is used to describe the processing that occurs in the order that is received. I mean, processing the data in the order that we receive them. So the same sequence, the same serial. And you have to know that language understanding, to understand the language, you should have sequential processing. But On the other hand, if sequential if sequential processing is needed for language understanding, simultaneous processing is needed for physiospatial manipulation. Simultaneous processing is the process of combining discrete and unconnected stimuli into a single group or whole to assist in comprehension and interpretation. So it involves the comprehension of the relationship of and between separate components, entities, entities, and its relation or position to the whole. So the matter not only the separate components, but their relation and the position to the whole. And you have to underline these two words, relation and position to the whole. So, one of the principles applied in the simultaneous processing is the whole doesn't equal the sum of its parts. Again, the whole doesn't equal the sum of its parts. I mean by that, the whole is greater than the parts. The whole is greater than the parts. It is about how much better things are together than as pieces. So the whole doesn't equal the sum of its parts. Now look at this picture. This woman or lady is named Sally. So, if you look at the picture, and I am going to ask you, what do you see now? You will say Sally. But look at this part of Sally. What is this? No one will say this is Sally or this is part of Sally. Just you will say, I see, for example, eye. Maybe right eye, you will say right eye or left eye, either. What about this? You will say another eye, maybe the right eye. But no one will say this is Sally or this is part of Sally. What about this? Just you will say forehead. What about this? Nose. What about this? Mouth. Never ever anyone will say this is Sally or this is part of Sally. But if we are trying now to combine these parts together or to put them together, before putting them together, you will say forehead plus left eye plus right eye plus nose plus mouth doesn't equal Sarah's face, because Sarah's face equals separate components and its relation or position to the whole. So if we putting them together in some sort of relation and in definite position definite position to the whole, in that case you will say this is Sally. So the whole doesn't equal the sum of its parts, and in order to understand or to be able to comprehend the whole, you should put the components together in a definite relationship and position to the whole. Now, look at this figure. If I ask you, what is this? Sure, you will say this is a square. What about the square? A square, the definition of the square is a plane figure with four equal straight sides and four right angles. This is square. Square is a figure with four equal straight sides and also four right angles. Okay, but what about this? No one will say, I see a square. Just you will say, I can see now two horizontal lines and two vertical lines. I think you agree with me that two horizontal lines plus two vertical lines doesn't equal square. A square equals separate components and its relation or position and position to the whole. And this is what discriminates between, for example, square and rhomboid. Rhomboid is a parallelogram with no right angles and with adjacent sides of unequal length. But the square is a figure with four equal straight sides and four right angles, but no right angles in rhomboid, and also adjacent sides in rhomboid are of unequal lengths. So square equals not equals separate components, but also it involves its relation or position to the whole. So the as we said before, the whole doesn't equal the sum of its parts. Now have a fresh look again at the meaning of the whole doesn't equal the sum of its parts, and try to apply this in your life and in your field, your major artificial intelligence. Now, have a fresh look again at the Sarah's picture, and then look at the parts and look at how putting them together in a definite relationship and in a definite positions and in definite positions to the whole will make Sarah's face. Now have a look at the square and its components and the relationship or the position to the whole, the relationship between the components and the whole. One other important topic or issue that is significant in implementing and executing artificial intelligence is the problem solving. What is the meaning of problem solving, and what about the steps of problem solving. And also, what about the different problem or the kinds or subtypes of problem solving?